For the last 5 years, I have been working on the whiteboard web application OrgPad you see right now. It is fully written in Clojure and Clojure script, and people often ask me why. Clojure is an absolutely amazing programming language, and I love it for 3 reasons. First, the language is really simple. Just move the parenthesis 1 left and you are done. In this video, I explain about 80% of Clojure you will need in 45 minutes. Languages should be simple, since it allows one to fully concentrate all the brain power on solving real business problems. Second, modeling your software with data structures is amazing. I see this as a spectrum for plain unstructured text to objects. Most of shell scripting happens on unstructured text, and every script has to deal with data parsing and serialization. On the other hand, objects introduce a custom language for every piece of data, which works differently and cannot be reused. The sweet spot in between are data structures, for example Clojure Eden or JSON. They are powerful enough to describe complex data, while there are standard ways for parsing and serialization. Data is completely transparent, no surprises, and a lot of general code can be reused for different types of data. The last reason for choosing Clojure is powerful interactive programming with REPL and hot code reloading. Normal programming consists of a cycle where one writes a code in text files, compiles them, which might take a lot of time, and then tests it by running the application. This makes the feedback cycle slow and feels like exchanging emails with your computer. There are specialized tools for accessing a running code called debuggers, but they are difficult and hard to use and require learning a completely different skill set compared to normal programming. On the other hand, REPL is your direct communication channel with a running application. Using it, you can execute arbitrary code and see the results, read the state in memory, and even update code of a running application. And it is done in the exact same way as programming of the application. Working with REPL feels like having a direct chat with your computer, where you can ask questions or give commands and the response is immediate. REPL is so important for me that it takes up almost the entire left screen of my desktop setup. When I started programming in Clojure, I didn't fully understand the powers of REPL. It took me several years to integrate it into my programming toolbelt and change old habits. Nowadays, I can no longer imagine programming without it. In this video, I want to showcase how we use REPL in OrgPad development on real-world examples. Integrating REPL into your toolbelt will require some time. But hopefully, this video will explain the benefits offered by REPL and give you some motivation to learn it. So let's see REPL in action. I'm using IntelliJ, so on the left side on the top you see some code here. On the bottom I have a running OrgPad application in development, and on the right I have my REPL window. And this might be familiar to you if you know some programming console for other languages, where you can just type some stuff. For example, I can do +1, 2, 3, 4, 5. I press enter to execute it, and I see that the result is 15. Similarly, I can write some other transformation. For example, take the numbers 0 to 9, increase all them by 1, filter only odd numbers and sum them together. And again, if I run it, I get that the result is 25. So this might be familiar to you even if you are using something else than Clojure. But as I said before, Clojure REPL is way more powerful. OrgPad Frontend is developed in Clojure script and runs in a browser. Backend server, developed in Clojure, runs on JVM. So we have two different REPLs in development. One connected into a running application in the browser, and the other one connected into the server. So I have two REPLs. This one is connected to the server, so I can, for example, run any Java here. For instance, I can type system/get environment function, and it will print me out what are the current environment variables on the server. If I switch here, I have to connect inside the browser, like this. Now I am connected into this browser window, and whatever code I type here, it is compiled into JavaScript, it's sent to the client, to the browser window, and then it's executed there. For instance, I can call JSAlert function, hello from REPL, and when I press enter, it's executed inside of this window. If I focus it now, you can see that an alert message is displayed here, hello from REPL. Okay, so let's use this knowledge to interact with these living applications. I have an example document opened here, which displays two nodes. There is a picture node with dog, and there is another node connected to it stating that dogs are fun. Okay, now let's fix it, dogs are fun. And so I can take a look at the state of this document. The main part of OrgPad is that it's a reframe application, so I have one big Clojure atom where everything is stored. If I just care about these units, I can access them like this. Let's get units from reframe appdb, and I get something which looks like this. It's actually quite complicated, but it's basically it's a map where keys are unit IDs, and then there is a map describing each particular unit. Let's just display the interior stuff, so it's a little bit easier. And there is a lot of stuff, but for instance, there is this unit with the title "Dogs are fun." We just changed. So this is the unit I care about. And if I just go here and write something else here, really fun. Now let me copy the ID for the unit. db-get unit, frame.db appdb for this ID. I get that the data are updated in real time. So whatever I do some changes here. For instance, there is the position of the unit. If I move it around, I get new position here. If I recolor this unit to something else, say pink, then I get here that the color is pink. So I can, in real time, I can access the data of a running application. I can do some computation with it. If I write some code, I can test it out on real data. So this is the front-end side, but I can also access the same data on the back-end. So let me just copy this identifier of the document. I will switch to the server. Let me store it as let me store it as ID. So it's a UUID encoded in base 64. This is what we use everywhere in OrgPad. And now I can access it on the server. So first we store everything in memory to speed everything up, so we don't have to go to database all the time. So there's something we call CacheDB. Let me get the org page of this ID, and I get all this data. So there are some, there's information when it was last loaded and what are the unit IDs and so on. I can OrgPage load OrgPage for this ID, and I get all the information which are stored in our database. Let me just concentrate on the units for now. And I get that this is this map. Again, as you can see, dogs are fun, really. There is the props that its color is pink. If I go back and revert it to blue and I run this again, you will see that now the color is color turquoise. And this is how we call blue. And so I have this data. Let me copy the ID of the unit again. And now I was reading it from memory, but I can also go into database. For that we use HackSQL. So, and this is the, let's say, dbget unit of ID book ID. And these are the raw data I get from database. There is the ID column, there is OrgPage column, which is again ID, owner column, and then there is this val column, which is an arbitrary JSON data where I store most of the information. And this is more Clojure friendly way. Under the hood in HackSQL, this function dbgetUnit corresponds to an SQL select statement getUnit, which selects star from units where ID is equal to the input ID. Normally when I work with this, I want to convert it back into a nicer Clojure value. We have a function which does that. For unit I can call it like this, and this is the format I'm mostly using on the server. So what it does is that it merges the arbitrary JSON into a single flat map, and also it does some parsing that some values like this unit book type, which are in JSON stored as strings, are coursed into keywords. So this is how we can read state of a living application from memory and do some interactions and computations with it. Very often, when coding frontend, I prefer to use hotcode reloading instead of REPL. Whenever I change the code and save the file, the changes are automatically compiled, sent to the browser, and applied there. It does not reload the page. Instead, code changes are injected into it, and the state is preserved. This is something most JS frameworks still struggle with, and it works in ClojureScript for many years. It completely changes how the frontend programming is done. Hotcode reloading is so powerful that for the first 3 months of OrgPad development, I didn't have any server. I was just building the frontend. There was no persistence, and when reloading the browser window, all the state was lost. But I didn't have to do this often, frequently running the same window for a few days while doing many improvements. Using this, let's add a silly button which will randomize colors of all nodes. First, let's do the rendering part. So I'm here where the code describing the components displayed in the top panel is. So let me copy the search button here. Let me modify the code a little bit. So it's a grid item called randomize colors, and it will be a button. I will call it panel randomize colors. Maybe there won't be any icon, but let's add a label. Randomize colors. Tooltip is not necessary, active is also not necessary, but let's make it a bordered button. So let's type button bordered. So let's do it like this. Now, as you can see, the application, it says me I didn't rename the function, so let's call it randomize colors, like this. And let's add it somewhere. Now the code loaded, but the button is still not visible, so let's add it to the panel right before the search button. Randomize colors, like this. Now you can see that the browser window updated, and I have here my randomize colors button, but it doesn't do anything yet. So let's add some functionality. For instance, we can do on-click and write some function which should happen. So let's do JS alert. Hot code reloading is also fun. Let's save it. Now when I click, I will get an alert stating that hot code reloading is fun. So I can change the functionality of the application while it's running. Now in OrgPad we usually do it differently. We have a centralized handling of mouse event, which is quite powerful. So let me switch to a different file where there is this multifunction up handle, which gets dispatched whenever mouse button is up. And so I have its dispatch according to 4 properties. So I have event type, I have the ID of the element on which the click occurred. So in this case, randomize colors. And I have some mode and modifier, which I don't care about in this case. So let's do that. We don't do any change, but let me just write some console statement. And gets reloaded. Okay, now when I click it, I get the hello message. So this is a function which takes state of the entire application as input and outputs a modified state called effects here. I can print it out. We use this DevTools formatter, so I can navigate inside this structure. I see what was the event and what is the state of DB and so on and so on. So I can play like this. Okay, so how should we do it? So first of all, we have to know IDs of all the nodes, all the units which we want to recover. And I have a function for that called dbUnit book IDs. And the input of this function is effects, and it will return me a sequence of all book IDs within my document. So let's print them. Book IDs, not ID. Okay, let's save it now. Let me just hide this. Okay, and I see that, okay, right now I have 13 units, 13 book units. I have added a few so we can see the coloring effect. When I have a single book ID, I can recover it using OPC unit update props function, which will take effects. Let me do first book ID, and then the props change, which is a map. So let's do props color and colors spectrum colors, like this. So spectrum colors is a sequence of all colors in OrgPad, and I do rand end. So I select a random color out of this vector. So let me save this now. And yeah, it just now recovers this single unit here. So now we want to recover all of them, and I can just use the Clojure reduce function. So reduce will take effects as one input and all the book IDs as the other input, and the function itself will basically call this. So let's do function input is effect and is book ID, and it will do all this. Just reformat it a little bit. And so it will apply book ID on the book ID random recovering. Nice. And when I save this, you can play with this like this. I can see all the nodes are randomly recovering like that. I have prepared a diagram explaining how this transformation works. We start with effects describing the state of the system before randomizing colors. Reduce computes a new state effects n, where the colors of all units are randomized. It changes the colors of units one by one. First, it changes the color of the unit ID 1, which produces a new state effects 1. For it, we change the color of another unit ID 2, which produces a new state effects 2, having 2 units recovered. Then we apply ID 3, and so on up to ID n, which produces the final state effects n, having all units recovered. Let's extend the functionality a little bit. Suppose that when I do selection of a few nodes, I want to just recover these nodes and no other. I can add an if statement, or an or statement, so I will either recover all units or I will recover dbget unit selection and it's non-empty. And I do it like this. I think it should now work. Yeah, it recovers only the selected nodes and the rest of the nodes stays the same. So I can play with my code like this. And it's a lot of fun, and when you get used to it, you can't really go back. And I still recall when many years ago, I think like 20 years ago, I was coding computer games using C++ and DirectX, and it was really slow, and always I had to like recompile and restart the game and test it out, and the feedback loop was really slow, and doing a lot of small incremental changes was hard. We can use REPL to do some interactive processing of data. For example, I have generated a small database of books using ChatGPT. So it is a vector of maps, and each map has 3 pieces of information. I have book title, I have the name of the author, and the year when the book was created. And I can play with this. For example, I can do some transformations. Let's say I will group by the books according to their author. I get a map where the author name is the key and a sequence of all books by this author is the value. Suppose that I want to remove the redundant information, so I can do, let's say, I can do map, and the function will take a key and will take a value. And the value, I can destructure here, so I can say keys title year, and I can output new pair key and say title. Title like this. Sorry, this is not a single book. It's and you can see the interactivity. I can quickly see that okay, this is not correct what I did, and I can fix it. So let's say let's do map books, and let's take the title out of them. And now I see okay, I have a person name, and I have a list of books written by this person. I can also convert it into a map. Okay, or for example, I can change this into a hash set like this, and I can play like this and do some random computation. So whenever you encounter some data and you just need to do some processing on them, it is often very easy to just load it into a REPL and play there. But I can do much more. I can display this data using my web server. And since I have a REPL, I can actually update the server while it's still running. So suppose that we want to create a new route called books. So Right now, I am getting a 404 error since the route does not exist, so the server doesn't know what is /books. So let's do it. Let's add it there. So first, I have to add it inside this table of routes. So I will do that. /books is, let's do site books. Let me reload this file so it gets updated inside living server. Okay, I have added the books route, but of course when I reload it I still get 404 error since I just said that there is this books route and it corresponds to this identifier, but I haven't said what should be done when it's opened. It's just the naming. I just named the route. So for that, let's create a new file on the server. Let's call new file Clojure namespace books. And let me just copy the books definition here. Like this. Okay. So now I can do some live processing here, but suppose that we don't care about books yet. And let me just write some handler. So let's call it handler. The input is a request and the output will be define here. Request, and the output will be just HTTP response /OK. Hello. Let's do a hello word here. Yeah, so like this. Let me now reload this file in REPL. Now I will go to this address and I still get 404 since, okay, I wrote this function, but it is not used anywhere yet. I have to also use it. So I will go to the core namespace where I have I have a map between the route keys and functions which should be executed like this. So let's do books /handler. And I have also to require it somewhere here. So let's do OrgPad server handler books as books. Now let's reload it. And when I reload the page, now it gets downloaded. It gets downloaded because I haven't specified a content type. Yeah, if I would just go here and I do orgpad.server.handler.books/handler with nil. This is the response map. I can modify it. Let's do the threading macro here. Let's add response/content type. Let's do text plain. Now I will just reload it. If I run it in REPL, you can see now in headers I have also the content type returned. Now when I reload the route, I will get my hello. And for example, so the response is a map and the request here is also a map. I can, for instance, print it. Request like this. Let's reload it. Yeah, now, okay, I get nil in this case, but in this case I will get my request map, all the data are here. I have some headers and so on and so on. So yeah, I can play with that. Okay, suppose that now we want to display books, so the easiest thing we could do is just to pretty print them like this. I reload it, when I reload it, when I show it, I have my small database of books displayed. But suppose that we want to do some HTML instead. So what we can do is we can do text HTML here and let's generate some HTML. The way how we usually do it is to use hiccup format, where hiccup format is a format where I will specify an HTML tag using a vector, where the first parameter, where the first element in the vector is a keyword describing the tag, say B. Then I have maybe some attributes, and then I have children text with some italic part. Let's do it like this. Okay, so I have my data structure, just nested vectors, and if I want to convert it, I just go hiccup HTML, and I can do on this H, and I get, in this case, object raw string. If I do str function on it, I get my HTML string, which is what we will be sending to the client as the response. So I can build a hiccup. It's a very strong, basically templating language, but I have the entire power of Clojure available to me. So let's do a few things. So let's do books by author, and we will group them by the author, and then let's do some processing on this. Do we? Maybe let's keep it like this now. So when we do orgpad.server.handler books/books by author, we can see it right now here. So what I can do also here is I can select the form and I can send it directly to REPL, and I will see the output. So this is a way how a lot of people use REPL quite often. Okay, so suppose that we want to transform it into hiccup format. So what we will do some let's map this. So we have our author name, and then we have books for this author, like this. So what we will do li as the element of the list with the name of the author. Now let's just ignore books for now. Okay, so let's save this. Let's run it, and I will see, okay, I have almost my list of all the book authors. If I want to turn this into a list, I have to wrap it by ul. And so if I will select this now and run it in REPL, I get my ul. Okay, so let's do the hiccup. Let's do the HTML here. So we will do string of hiccup /HTML of books by author. Let's add the requires. Let's reload the namespace. Okay, now if I reload the browser window, okay, I get a list of all the book authors, which is pretty nice. Let's add their books as sublists. We do it. Let's do a list here, ul, and then we do for all the books inside books. And usually we just do some quick destructuring here. So let's do title and year, and we can maybe just display the title of the book. Let's do like this. Yeah, so let's again, if I execute it like this in REPL, now I see the full hiccup. If I reload it, I see it also in my browser window. And for example, what we can do, we can also add the year. Let's add it like this in the parentheses right after the title name. So if I reload it, I can immediately see it in my browser window. I'm doing live updates, and recall that this is really a huge Clojure server which runs and does a lot of different things, and I'm updating it while it's running. So it's super powerful. And I can do more things here. For instance, I can sort by year, and it will reorder me the books. They're sorted according to the year when they were written. So I can play with my data live like this, and again I can do immediate interactive changes in a running server, and I can see the results, and the feedback loop is super powerful. We have seen how interactive programming works in development using REPL and hot code reloading, both front-end and back-end. The instant feedback loop is so addictive, and it is exactly how I do all my development. And these are no toy examples. It runs about 110,000 lines of Clojure code. But REPL is even more powerful. There is no reason why it has to be connected just to my development machine. Instead, I can use an SSH tunnel to bind a port of a remote machine to a port on my machine. REPL can then connect to a machine running an OrgPad server in the cloud. So for example, I can just do SSH OrgPad test REPL. It will run me an SSH tunnel. And now if I go back to IntelliJ here, and I do run, I have here my staging REPL. So right now I am connected to a staging server in Hetzner Cloud, and when I will run something here, it gets sent to the Hetzner server and it will execute there, and it will display me the result which gets sent back. So I can so now I am running inside of cloud. For example, we can just take the books route we have developed just before, and we can live reload it inside a server running in cloud. So if I go to test.orgpad.com/books, the answer is 404. The route is not found there because we haven't done it yet. Okay, but we have changed 3 files, so I will just reload them like this. The first one, the second one, and the last one. Okay, now it states me that the server handler was restarted. Now when I will reload it, I get my book database. And this is in a live running server inside cloud. OrgPad uses Stripe to process credit card payments. We built the entire integration in just a few days using REPL. First, let's give an overview of Stripe integration. The user first selects the subscription plan in the OrgPad checkout page. It is then redirected to the Stripe checkout page to enter credit card information for which we are not certified in OrgPad to handle directly. If the user cancels the payment, he is redirected back to the OrgPad checkout page. If the payment is successful, he is redirected to the OrgPad payment page containing information about the ongoing subscription. Stripe processes the payment in the background. When it is successful, it sends a message back to the OrgPad server using a webhook. When our server receives this message, it creates a new subscription for the user in the OrgPad database, which enables paid functionality in OrgPad. There are also other types of messages we receive from Stripe. When a subscription automatically renews, we extend its duration in the OrgPad database. And when the automatic renewal fails, we send an email to the user informing him what happened, asking for an update of payment information. It is quite easy to send messages from OrgPad to Stripe from a development machine. But receiving data back using a webhook is tricky. The recommended way is to mock these messages using Stripe CLI. But when working with a complex API such as Stripe, it is best to work with messages as close to the production ones as possible, so mocking messages is not great. Another option is to build an SSH tunnel into my development machine, which I didn't want to set up. So instead, We have built the entire integration on our staging server, which was frequently updated using REPL and sometimes redeployed when necessary. Let me show this a little bit. I have an account in our staging server, which is currently running the free plan. I can upgrade the plan by clicking this button here. I get displayed the selection of the plan, so let's say I will choose yearly professional subscription. I click again and I get redirected to a Stripe checkout website page. And this page, the URL of this page is generated using this Clojure function here on the left, which basically sets stuff like the current plan, and whether it's yearly or monthly, and my email address and a few other things. And we can also modify it here. For example, suppose that I would also like to collect billing address from our customers. I can set billing address collection, and it takes a single parameter, which is one of two possible constants. So it's a session parameter, session create params dollar as a subclass, billing address collection / required. And with this, when I reload my code using REPL and I go back, and then I click for the payment again, I get redirected to a different URL where the billing address is currently displayed. Okay, let's pay for Stripe now. I will use my personal credit card information, so don't look. Let's do Czech Republic and non-existent street in Prague. Let's pay now. Now it's processing, it's checking my credit card information. And it's successful, so I get redirected back to OrgPad. So we created a new subscription for the customer and we display information here. We have also downloaded a receipt from Stripe, which can be displayed like this. There's the billing address and other stuff. Let's take a look at some data about this customer and about the payment, and we can experiment a little bit with Stripe API. So first we should take a look at the messages we received on our webhook, and it's a db get Stripe events. This displays all messages, and I think the one related to this concrete payment are the last two. And yeah, so we have some information, like where is there's some data. It's received right now. There's one is of type invoice paid, and another is of type checkout session completed. There's the address and stuff like this. So based on this information and based on the customer ID and some other stuff, we are able to create a subscription in our database also. So we know who is subscribed, who is paying, and so on. This is a code which processes the webhooks. So when it receives a webhook, it verifies that it is coming from Stripe, and then it does some JSON parsing on it because Stripe sends JSON, and then it will store it in database, and it will process the event according to its type. So there is the customer subscription update, invoice payment failed. There is invoice paid, and there are some others which are not handled, but we store everything. So this is how we process webhooks, and this code was completely written using our staging server, where I was writing the stuff and reloading the code and testing it out with Stripe like this. We can also play a little bit with Stripe API. So let's do. So dbget subscriptions will return me all subscriptions, and if I take the first one, it's this newly created subscription. So I have some ID here, and I have some customer ID. The tier is professional. I have some dates. Let me convert it a little bit. So let's db parse /subscription like this. I get it as a single nice Clojure map. So I have a tier here. I have that it was paid in US dollars. It was paid using Stripe. This is the cost in euros, or euro cents more precisely. It has some subscription ID which is taken from Stripe. It auto-renews yearly. And I have some customer ID. So let me copy these IDs. So I have a subscription ID. Let's store it for later. And I also have a customer ID. And now with these two IDs, I can go and query Stripe API. So we have the subscription object, which has the method retrieve. Let me import the Java class from Stripe. And it will take the subscription ID, and it will go to Stripe and the development version of Stripe, and it will retrieve me this model subscription object, which is basically just a JSON wrapped inside of an automatically generated Java object. And we can get JSON out of this. I think it's to JSON like this. It's great that IntelliJ can really understand Java, so the completion is really helpful when you do a lot of Java programming in Clojure. So if we do this, we just receive the string, and we can do parsing. We use JSONista in Clojure, and we use this JSON to CLJ kebab case keywords, which parses it from JSON and also converts keywords to kebab case, which is the standard format in Clojure. So we have this information. Let me just enlarge the REPL window here. So I have some information about the customer, about the subscription, sorry, not the customer. So I have the customer name here. I have when it was created as the Unix time. If I do this, if I do date parse for this, which is our wrapper for date, I should receive that, yeah, it was created just now. And yeah, I have some other information. There is the price, the plan which was used, that it was paid in US dollars. Yeah, that is some other stuff we could play here. What was the price here, for example? So I could store the price ID. I think it should be price retrieve, yeah. So let's import the class price ID, and let's do the same JSON stuff. So to JSON and JSON to parsing. I will receive that the price is $49.99, and Stripe always integers are used, so this is in USD cents. And there is also what is the product, so I could also query the product number. Let's copy it like this, dev product ID, and I could do product retrieve again. the same pattern. So I will do the product ID, and I do to JSON and JSON kebab case parsing, and I will receive that. Okay, this is the professional tier. Yeah, when it was created, when it was last updated. Yeah, what is the price of it, and so on. So I could also query the price, and I could play with a bit with Stripe API like this. So this is, for example, the customer stuff, the subscription stuff. I could also retrieve the customer. So let's do it like this, that customer ID. If I keep, for example, product ID here, I should get some error, I think, from Stripe, yeah, that it cannot find this product ID as a customer. But if I query the customer ID, it will work correctly, and I get information like my name, I get my email address, I get the address I entered there, and some other stuff, and yeah, I can basically go and play with Stripe like this. And of course, this was only the reading part of it, but I could also do some modification. Basically, I would combine this sort of API exploration together with reading Stripe API documentation and reading examples on their websites, and with this we can easily do some changes, and it's quite fun. Definitely much better than just going blindly and reading stuff in documentation without actually experimenting. Since we can connect REPL to our staging server in Hetzner Cloud, it is also possible to connect to our production server. When I mention REPL to production, this idea is really scary to many normal developers. I can connect to our production server, run some arbitrary code there, or even update its functions. This has to be dangerous, and your server is broken all the time, destroying customer data, and so on. This is what these developers imagine. I think the famous Spider-Man quote is very fitting. With great power comes great responsibility. REPL to production is an amazingly powerful tool, allowing us to do things which otherwise would be difficult or even impossible. But one has to be very careful when using it and understand the underlying system a lot. And sometimes you will burn yourself a little bit. For example, I once accidentally broke JSON serialization into Postgres database without testing it before. After 1 minute, we got a message on our Discord server saying that something is wrong. We quickly turned off the server, restarted the old version, and then spent the entire evening fixing broken data from logs and backups. So I'm no longer touching DB serialization using REPL and without testing. But REPL to production is still very useful. So let's connect to our production server using REPL, and let's do some computations with some data there. So I will again write SSH OrgPad prod REPL. It will open my SSH tunnel. Now I go to IntelliJ and I say run production here. And right now I'm connected to our production server. And of course I have to be careful here, because say if I would run some heavy computation here, I could overload our server and it would stop working. So it requires basically to know what you're doing. But we can play a little bit here. For instance, I can query the number of current number of users. So we have the cache db get users. It complains that, okay, I need to do some requires here first. Just these two, and maybe also let's require OrgPad server db core sdb. Fine. So now I can do cache db get users. HDBDB. I'm not going to print it because it contains a lot of private information of our users, but I can at least show you the count function applied on it. And I get that currently we have 37,000 users registered in our website, and it's growing every day. Yeah, now you can see that it is okay, I'm connected to a production infrastructure. So let's do some computation with some data I can actually show you here. And one type of data I can show you are some high-level statistics. So let's take a look at statistics involving countries. So we know by IP address when you connect to OrgPad which country you are from. And we are aggregating statistics from which countries people use OrgPad. And these statistics are stored in admin.db. Get countries. Yeah, we'll need to require it also. Administration admin.db. So let's get countries. And it will print me a lot of data, but it's basically a map which there is the country code as a key, and then I have some other stuff. And the largest is this vector of weekly activity. We use these to draw some plots, how the usage changes over time, some tiny plots. That's super efficient, but we don't need it now, so let's remove it, let's hide it. So let's just take the value, we don't need the map, and let's do map dsos country weekly activity, like this. And this is, okay, I forgot the input parameter here. Okay, like this, and now this is a much nicer, smaller set of data. So I will just store it like this. And now, for example, we could ask, okay, which countries use the OrgPad the most? So that we can use the sort by function. By country, say total time spent. And so let's do the largest at the top of countries. We will, of course, we will get. Let's take maybe top 10 countries using OrgPad the most. And we get that the top country is Czechia. We have a lot of customers from Czech Republic. We have 30,000 customers. So more than 75% at the moment. They created 66,000 documents together, and they spent a lot of time. Actually, the time here, it's the total number of seconds they spent in OrgPad. And this time is by active work, actually doing something. So let's convert it maybe a little bit better. Let's do some, let's update the, let's map FN country keys. So let's do total time spent as country, and let's add something more readable. So let's do assos country total time spent, and we have this function uc slash how is it, seconds to string, I think. It's called unit conversion. Let me quickly search for this. So unit conversion. So we have size conversions, and we have seconds to string. Okay, let's require it here for total time spent. Of course, and now you can see that the total time spent in from Czech Republic is 2,000 days. The next country on the list is Germany with almost 100 days, 700 users. We have United States of America, 40 days. We have Slovakia, Peru, United Kingdom, Panama, Singapore, Canada, and Switzerland is the last one in the top 10. So we can play with the data like this. The computation runs fully in production, but it's useful when you want to take a look at some data, do maybe some quick experiment. And of course you have to be careful to not overload the server. We also use production REPL to run one-time conversions. For example, in a database, when we change the database schema, we want to change how some values are stored, we will just run the conversion, we will run these conversions once and we will be done. So for example, this is one of the files. I have all these files are stored under convert namespace, convert package, and so these are basically one-time conversion. For example, we have seen that the position of a unit is stored as a vector containing the x-coordinate and the y-coordinate, but in the past we actually stored these coordinates separately in JSON, so they were stored under x and y values, and we did the conversion that we loaded all units from database and we updated them in JSON. Of course, this could also be written as a SQL migration, but sometimes it is much easier to do these conversions from Clojure, and also you might be doing some other complicated stuff which wouldn't be possible directly from SQL. So it is really useful when you write some one-time conversion of the data, you test it up in development, maybe on a backup of your database, and then after you deploy updated server, you just run this conversion on all the existing data and everything is fixed. Similarly, we can also use REPL to do quick bug fixes. Sometimes we are told by our users that they maybe notice some bug and it's something really easy. I can just fix it in our server code and I can immediately reload the fixed functionality without having to redeploy the server. And so it's much faster and it doesn't reload all our customers. So redeploying takes a little bit under 10 minutes and reloading by REPL can be done in 1 second. So it is way faster and better. So when it's possible, we try to do it. Another example of a functionality we run manually are things which do not happen so frequently, and we can just do them from REPL, and sometimes there are some extra inputs. An example of this is upgrade of a subscription where either an organization, for example a school, decides to start paying for a plan, or when you send us a wire transfer. So it is possible to pay by wire transfer, which is quite popular in Czech Republic. So you get this QR code, you scan it with your mobile phone, you will send us money, and when we receive the money in our bank account, we will go and manually activate your subscription. So for that I will need to know the customer ID, which is basically what's stored here. So let's activate the yearly subscription for this account. So this is encoded in base 32. It is a user ID. Yeah, it complains again about require. Something I would like to fix in production. Okay, UID like this. So if I do keep user of this it will, yeah, this is my newly created user account I did just now. Okay, and I want to activate a subscription for it. So we have a function we can run here. So subscription /create subscription. And this function takes an input map describing everything. So the input map is subscription ID. Say I do user testing. Then I have user ID, which is my user ID. Customer ID is for Stripe. There is the end date. Say it will be a yearly subscription, so 1 year from now. Let me reformat it here. So it will be a yearly subscription. Tier is, say, professional, and that's probably it. I mean, normally I would also set up the value, the amount which was transferred, but in this case I don't want to have it in our accounting. Okay, so let's do it like this. And the subscription is right now created, so if I again load the user, I will see that there should be a subscription ID here. So user now has a subscription. If I do subscription slash active user tier, for example, for this user ID, I will receive that it's tier professional. Can also get the active subscription for the user, and it's this subscription we have just created. If I go back to the browser and I reload the page, now you can see that I already have a professional tier. In the setting, I have a currently professional plan valid for another year, and it will expire. So I can do these one-time activations and changes, and sometimes people write to us that they would like to upgrade for a higher tier, or they want to do some changes in their subscription, and we do a lot of these things manually, and it makes sense to automate them at the moment where we have enough of these changes all the time that it would be faster to automate them instead of doing them manually. For the last example, I needed to generate accounting reports from Stripe. Basically, after each month, we create a few tables which summarized all the transactions which happened in Stripe for different currencies. We display some information about the customers, like the country they are from and the total number, and then our accountant does the accounting on them. And I needed to generate these. The standard way would be to create some mock-up data, build the table generation out of them, and then when I would spend a lot of time mocking and creating these examples, I would run it in production and I would see whether it would work or not. As I said before, I don't really like this approach because you're working with some random data you have to invent. It's a lot of work that you have to invent these data, and they are not accurate. So instead I decided to take the real data, and I created this entire namespace while I was connected to our production REPL, and I was reloading it there and testing it directly. And so I basically waited for the first 2 months of payments, and then I used the real data from Stripe to build this infrastructure. And this was like the core of this namespace was created over 1 day, and then I did some updates here and there as we were adding more functionality. And so basically what it does, it first will generate a request to Stripe to create an report. I think it's in a CSV file. So it will generate this Stripe report of this type containing these columns, and when Stripe will be done with generating the report, it will send it back to us using a webhook. And so when we will receive this, we will do the this where is it? Retrieve payout. There is this download report function which will run, and it will take the report, it will process it, it will do some transformations on it, and it will also access Stripe API to download some further information which are missing there. Then it will store the report data into database, and it will generate a PDF which is sent to email to us and also to our accountant. And we have also some infrastructure for updating recomputing the report, and then it will generate basically how we do it is that we generate the HTML page with the data, with the tables, using Hiccup. Then we render it, and then we use a separate server which runs Chrome using Puppeteer, and it will produce a PDF out of this. And we already had this infrastructure for creating screenshots of documents in OrgPad, so it was just the easiest way to generate PDFs. So we have the PDF, and then we have we do the Hiccup stuff, and we print it. And basically the core of the processing are these process payment records according to the payment. Like if it's a fee that we pay to Stripe, it does just some renaming and some quick processing. The most complex is a charge, where we will have to basically process a lot of stuff. We will have to do like the receipts, connect it with a receipt, and so on. Like it's not super easy or super nice, like the stuff we get from Stripe, and we have to connect it with the stuff we have in our database, and we do a lot of different computation here to make it working. But it works, and it was fully developed in using production REPL. And whenever I need to do some changes in this code, I will just connect to a production REPL and do some experiments with live data there, and it's the easiest. For example, recently I added a new category called refund, that when we refund some charge, we put it in a separate table, because so the refund is no income for us, but we still have to pay a fee, pay all the fees to Stripe. So we wanted to separate it like this, and I didn't knew how to, for the given refund, basically for the given payment, how to find who was refunded, because I want to display the name of the customer. So I played a little bit using REPL with Stripe API, as we have seen before, using the real data, and I found that there is this refund object, and there is the reason and charge, and I can also find the customer ID, and from that I was able to basically fill this information here and add a new table. So in this case it was really very powerful to develop it directly in production using REPL, because I could use real data, and there was no danger to basically the server or our customers, because I was working in a completely independent namespace on a completely new database table just created for the reports. So it couldn't interfere with anything running on the server. We have seen examples of how Clojure interactive development works, and it completely changed the way I do programming. Instant feedback loop is great, the productivity boost is amazing, and it is a lot of fun. I have always enjoyed when I could build something new and play with it, see what works and what doesn't, and improve it a little bit further. I would love to hear how you use REPL and what are some tricks you have discovered, so let me know in the comments. If you want to support our work and see more videos like this one, check out OrgPad. You can use the promo code REPL to get 20% off. Thank you so much for watching.